For number 8 in lesson 16.2, they asked us to go back to common log, and the key to this little rascal is that you can do step 1 and step 2 quickly by just writing the logs of both sides and putting the exponent off to the side. Then we solve for x by dividing by the log. Then we move the 1 by subtraction, and then they don't like it to have it say divided by 5. They want you to rather write in your software, this is your exact answer, 1/5 of the ratio of your logs, minus 1. So you can, if you have different numbers, you notice this 5 came from the exponent, and the log 4 is in the numerator, log 6 is in the denominator, and you're subtracting the 1 out to the side. So then when you enter that into the computer for the, or in the calculator, you get about, probably shouldn't use that eraser, about a negative 45 thousandths. And always, if you like good results, you can put back into your calculator 6 to the 5 times a negative 0.045 plus 1, and that should give me 4. So my calculator, I can just put 6 to the 5 times negative 0.045 parenthesis plus 1. And see how it's close to 4? And the original said equal to 4, but that's because we rounded. So remember, checking your answers a wise move. Okay? About 4, so it checked out. That's the key to number 8. And the rest of the exponential equations, check your answer. Okay, we'll go on to number 9. 4, 3, 5. I think this is when they stop telling you which logs to use, so you decide for yourself whether you want to use the common log, or the natural log. Remember, common log is log on your calculator, and then natural log is that Latin word, and the initials is ln. Logarithmus naturalists, or something like that. So for number 9, because it has a base e, you're probably going to use natural log. So the exponent's quite interesting. It is a ratio, 2x minus 1 over 3, and it's equal to 290. So whenever you need to find an exponent, use the logarithmic properties. So I'm going to do step 1 and step 2. E is by itself already, so yahoo! This base is by it, or this power is by itself already. So the next step is I write the exponent off to the side. Don't want the 3 there first. I want the 2x minus 1 over 3 times the log of e. Oh, I wanted to use natural log. That way this is equal to number 1. Now that I made this mistake earlier today. If I do it to one side, I gotta do it to the other side. Have you forgot to do that in algebra before? So easy to do. I use natural log because if you take the natural log of e, you get the power of 1. So then, this is equal to 1. So 1 times anything is the thing. So I just have my 2x minus 1 equals my natural log of 290. That is a number, but it's not pretty. E to what power is 290? It's a decimal. So now you got to remember your algebra rules. To get x alone, I first get rid of the division of 3 by multiplying. I put a 3 up here and I put a 3 in front of here, these cancel. So I have 2x minus 1 without a denominator. Then I have 3 times natural logarithm of 290. And remember, it's x I want to isolate, so the next thing I move is adding 1 to this story. It's quite a lot. And then divide by 2. Everything's over 2. So this is your exact answer. Because these cancel. And then I do my approximate answer, 9.005. Put it in my original equation, and it does check out. So I was going to look in my, I believe you can just write 3 next to the ln. You don't have to put a sign next, you don't have to put a dot or a star or anything like that. You can just put 3 times, 3 ln means 3 times natural log. And so only thing new here from this lesson is that you learned you could take the natural log of both sides of an equation. Then the last lesson we learned to multiply, we can change the exponent to a multiplier. That is nice. There's no guesswork involved. It says use logarithms to solve this equation. X to the second. This is good for your math testing next week too, if you're a sophomore. Juniors and seniors, you'll be working on other homework for those couple of days, and then we'll review this module 16, because this is the last lesson in module 16. Then we'll have our module test for everybody, and it'll count as a semester test for the seniors. All right, this is not alone, so I need to move the 102 first. That's step 0. So if my power is not alone, up high I can multiply. So this is really 10 to the 2x, and that is 19. Now, since this is base 10, it would be smarter to use common log. So it's 2x log 10 equals log 19. And log base 10 of 10 is 1. Just a 1, so I end up with 2x is log 19. One more swoop of the pen. We've got our exact answer. The 19 came from this moving of the 102 over, and the 2 came from the factor of x. And then my about answer is about 0.639. I don't trust it. I can put it up here. 10 to the 2 times 0.639 plus 102, it's about 121. Now, I think I rounded, I left this alone, so it's just a freckle less than 121, but remember, rounding that exponent makes it, let's see if I've got that in here. There it is. So if we put it up there, I got 120.967. So, yay, calculators. Okay, number 11. One more. Just solve it whichever way you want to. Now the base is 5. You can use common logarithms or natural logarithms. Neither one of them will make the 5 go away like the other ones. So I'm just going to use the common logarithm, log 5. Don't forget to take the log of 44. And we got to do our algebra. Move the log 5 away from x by division. So I have x divided by 4 is the log of 44 over the log of 5. And then to move something being divided, the inverse operation is multiply. So I just put it in front there. So x, these cancel. Exactly 4 log 44 over the log of 5. And about 9.405. So click, 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 click. Here's my exact. Here's my approximate. Number 12. This one's only one application. There was lots of applications to choose from, but I picked this one because we've already done compound interest. And if you read the story, it says the amount of A in the bank account after T years is given by this compound interest equation. A sub 0 is the initial amount, so that's what we started with. R is the interest rate, written as a decimal, of course. Suppose there is, I start with $580. So that's this A sub 0 guy. If the interest rate's 7%, that's my R number. I write it as a decimal, up as the numerator there. How many years will after how many years will the amount quadruple? Quadruple means 4 times. So they want you to round it to the nearest tenth of a year. So this side, this final amount, is going to be 4 times my initial amount. So if I take 4 times 580, that's my left side. And if you guys' story said triple, you'd have 3 times. Then my initial amount is 580 times my 1 plus my interest rate over 7. And this is what they gave me. They gave me the 7 to the 7t. So they must be compounded at 7 times a year, so whatever that's about. The point is, I am missing the t. We are not going to use a graph to find it. That's what we did in our module 13. So I have to isolate the power by dividing both sides by 580. So I just have 4 out here. So if yours said triple, you'd have 3 out there. Or double, it'd be 2, whatever. Okay, this cancels, this cancels. Then you could add, you could put this in your calculator and get a number out. Okay, so that would be 7.07 over 7. You know, if I took this times 7 and then added to 0.7, just to make it a little less typing. And that would even multiply out nice, you know, or divide out nice. So you could even have 4 is 1.01 over to the 7t. 7 goes in there. So we got it simple. Now all I have to do is apply my logs. So if I take the log of 4 to equal 7t times the log of 1.01, I solve for t. Write this log of 1.01 on both sides. I'm going to go ahead and put that in parentheses because it looks like L's and 1's and all that stuff. So last thing I have to do, and they don't want the exact, all you have to do then in your calculator is to get rid of this 7, you divide by 7, divide by 7. In your calculator, you can just put in then divide by 7. Put in your ratio divided by 7. That gives your t. So let's try it. Oops, I got to get down here. Fraction. Got my fraction. Log 4 over log 1.01 divided by 7. So mine's about 19.9 years. So you can simplify it as much as you want, or you can leave this alone, you know. It's whatever you're comfortable with, your numbers. It all comes out in the wash for number 12. I'll zoom out on that so you can see it all. Just take a picture of it if you want. And that one. It's got my numbers from the story, got my formula from the story, did a little arithmetic to make my calculator game a little easier. And you got to know the steps of Algebra 1. Now 13, we're all different pretty much, so I'm not going to go through all of the choices you have there for 13. I think there's 1, 2, 3, 4 of them. They're all, I think, using base E, so I'll just do one of them. And just remind you, remember with, it says drag and drop each solution, so you end up having to solve every one of them. Okay. So if I have 8e to the 4x, got to get rid of the 8 first because I need that e to the 4x alone. And then easy mistake, oh, that's an x at the top, sorry. Easy mistake is I'm going to take the natural log, so it's 4x, natural log of e. This morning I forgot to take the natural log of the other side as well. I just get, you know, happy when I can take this as a value of 1, remember? So it's just 4x is natural log of 3. So x is, and you don't have to type that in. You could just put in your calculator, find out what the natural log of 3 over 4 is, and that is 0.275. So every one of them on number 13, just don't forget to isolate the e, use natural log so the base goes away. On the left side, remember to take the natural log on your other side, and have a every answer should have a match. Okay? Does anybody have one other one that you want me to? Oh, I guess there's only 4 of them. B, you just divide by 8 first. Or for me, you just divide to find the answer. C, you divide, then you have to do a couple other moves. And D is subtract, then divide. Then you've got your answer. Just use your algebra skills. You can do it. And map on Monday, Tuesday, Wednesday. Review on Thursday. Test on Friday for next week. So there'll be a space between the lessons and the test. So there's no reason everybody can't have their lessons finished. That would be amazing.